Hi again, James Walter Apitan here, and this video I will be presenting the results of experiment 2, Python literals and operators. The objectives of this experiment is to become familiar with the print function and its formatting capabilities, to practice coding strings using literals, and to experiment with Python using various operators. So let's start. For the first try of the code, number one will be to create a source code for the given scenario below. Here is the given scenario or the expected output. So we will use a one-line piece of code using the print function as well as the new line and escape characters to match this result. So I have inputted these characters, this code, and as you can see here, we have many quotation marks. And for your information, that quotation marks are full of single and double quotes. So first we'll put it here. And as you can see, there are several single quotation marks around the double quotes, and double quotes are used to display the strings, while the single quote functions the same as the double quote. I can display now this double quote because using the single quote as a function of the same as the double quote. So in every double quote that will be displayed here have are inside the single quotes, while the strings that will be displayed here are inside the double quotes. So let's try this program. And as you can see, it is the same as here. Next, we'll use the exponentiation arithmetic, and we will see what will be the result. And there, like so. As you can see that the first line is full of integers, are all integers, so that the result will be an integer. While the second to third line, it is not an integer but a float or a decimal. That is because the second and third line consist of an integer and a float. Because of the period here, Python recognized this number as a decimal. And here we have two decimals, and that will be the result. Also a decimal or a float. And the symbol for the arithmetic, no, the symbol for the exponentiation arithmetic rather is this double asterisk. While for the single asterisk, here is the multiplication arithmetic. So let's see what will be the result and the difference between double and single asterisk. As you can see, the numbers are different because Python recognizes the single asterisk as multiplication. That's why 3 times 2 is 6, while the double asterisk, Python recognizes it as a exponent. So 2 raised to 3, 2 times 2 times 2 is 8. You can see here. Next, we will use division arithmetic, and we will see the results. What will be this arithmetic be? And as you can see, there are no whole numbers. So Python recognizes division operation as a decimal. So 6 divided by 3 should be 2, but instead it is 2.0, which is a float or a decimal. Next is the integer division. Integers are all whole numbers, and it represents a double slash. So let's see here, like so. And as you can see, the first and the fifth line are all integers because from the code, it is all whole numbers. But from the second to fourth line, as you can see, there are floats here, here, and both of these here. And the sixth line, you can see it's also a float. And using the integer division, based on the rules, the integer division or the floor division rounds the value to the nearest whole number and the lowest integer. But also with the period in some lines, because as you can see here, it will still display a float value or a decimal. Next will be to predict the results when we use this code there using a classic division which represents the slash instead of a integer division or floor division that be represented as a double slash. So first, let's see what will be negative 6 divided by 4. I presume that it is 3 over 2 will be negative 1.5, and both of them have negative, so the two lines are negative 1.5 as and as expected. Next will be to see if these are the same results as the previous one. And as you can see there, it is not the same because integer division are, as observed here, the result will be different as the classic division will display the exact value, while the floor division displays a rounded off value, which means that negative 1.5 rounded off to the nearest whole number and lowest integer, it will be negative 2, because if it is a positive 1.5, it will be 1. And as you can see here, because of positive 6 integer 4. Next is to observe the output for each remainder arithmetic. The remainder arithmetic operation in Python represents the percentage value or the percentage symbol. So let's see what this result be. So first, I'll predict that 4 divided 14 divided by 4 has a remainder of 2, while 12 divided by 4.5, 4.5 times 2 is 9, That will be 3. So we will now see that if these are true. Yes, it's true. 14 divided by 4 has a remainder of 2, while 12 divided by 4.5 has a remainder of 3. Next is to observe the output for the addition arithmetic. Let's use this code here. There. As you can see, negative 4 plus 4 as the mathematical expression negative sign plus positive is subtraction. Negative 4 plus 8 is negative 4 plus 8 is 4. Negative 4 plus 4 is 0, while negative 1.1 is still negative 1.1, like so. That's why it is 4.0, because the 4 here is a float because of the period. Next is to try these exercises. First, I'll predict what will be the result before applying it here. Sorry about that. Now, for the print function of 2 raised to 4 is 2 times 2 times 2 times 2. It will be 2 times 2 is 4, 8, and 16. It is 16. Next is to 2 times 4. The 4 here is a float. It will be 8.0. Next is a integer. 4 times 2 is 8. Now let's see what will be the result if we use this code and run it here. It's the same. 16, 8.08. Next here, negative 2 divided by 4 is negative 0.5. And 2 divided by 4 is 0.5. 2 integer by 4, 0.5 is lower integer, so it's 0. And negative 2 integer by 4 is also, nope, it will be negative 1. So it will be negative 0.5, positive 0.5, and next will be 0, then negative 1. Now let's try it. Negative 0.5, positive 0.5, 0, negative 1. Next is to use this code. But first, 2 divided by negative 4 will be negative 2 as the remainder. Negative 2, this is 2 divided by 4, it's positive 2. And 2 raised to 3 raised to 2. 3 raised to 2 is 9. So 2 raised to 9. So we'll have 2 raised to 4, 16. Under 2 raised to 4 is 16. 16 times 16 is 6, 5, 2. 256 times 2 will be the ninth. We'll have 256 times 2 will have 2, 1, and 5. So the result is 512. Negative 2, positive 2, and 512. So let's see if these are true. Okay, so negative 2, positive 2, 512. And there you go. For the conclusion, it is shown that there are multiple symbols that Python recognizes to perform mathematical calculations. For the division operation, the classic division displays the value in a decimal form or a float, while in floor division, it displays the value rounded off to a whole number and also to the lowest integer. Also, in the arithmetic operations like addition, subtraction, multiplication, so on and so forth, it still displays the expected value and the functions are the same as it should be mathematically. For the recommendation, it is recommended for programmers to look carefully in the codes being run and take into account the symbols being used to have a better result. Well, that's all for this video. I am James Walter Apitan. Thank you for watching.